Hi, welcome back to example 2 for 5.3. In this example, we're just going to identify some of the features of this sinusoidal function, and then we will go ahead and graph from 0 all the way to 720 degrees. So if we look at here at this equation, we notice that not all the parameters are used. So I notice there's just a value for D right here, as we can see, and we can also see that C is 2. So I notice that A and K don't really show up in this equation at all. So that doesn't mean they're 0, it just means they actually have a value of 1. So what is the amplitude for this function? So I'm going to start by saying A is equal to 1. So when we look at the equation, there's actually a 1 in front here. So the value, or the parameter A is always in front of sine. It's always being multiplied. So I know there's a 1 here, so I know that A must be 1. So that just means that the amplitude is unchanged for this sine graph, and it's still going to be equal to 1. All right, what about the period? Well, in order to find the period, we need to know what K is. So K is 1, and I know that because I don't see it being used inside of here, this part. So K is always kind of multiplied in with this bracket here, and I don't see a 2 or a 3 in front there, so I know K just must be 1. Also, if K is 1, there's no horizontal stress or compression, so that means the period is going to stay unchanged. So the period is still going to equal 360. Okay. If you remember, I also gave you guys the formula in the last video. Period equals 360 over K. Well, if K is 1, then we know we just get 360 for the period. So, all right, the phase shift. So the phase shift, also known as the horizontal translation, that's the value of D. So I can tell in this equation that it's 45 degrees. So therefore, shift right 45 degrees. Okay. So because D is positive, we're going to go to the right. Describe the vertical shift or vertical translation. So that's the last part here. C equals 2. Therefore, shift up 2 units. Okay, now we just get to graph the function from 0 to 720. So let's go ahead and grab, or just kind of draw our axes here. So I'll mark off 720. Okay, so I think a nice way to do these graphs is I always kind of start with the shift first, okay, the value of C, because that's going to act as the middle of my graph. Okay, so if you remember, sine kind of looks like this, and there's that middle line that goes through. Okay, I call it the center line. So when we have a vertical shift, that center line moves up. Okay, so I usually kind of start to draw that. So I'm going to mark off 2. So the value of C, I always mark off on the graph at 2. This acts as like what I call a center line. Okay, it's an easy way to get the graph. Okay. So with this center line, that means that my sine function is going to oscillate about that center line. Okay, and I'm going to have the amplitude between the max and min values. So I'll just say graphing tips. Start with C first, okay, and then focus on the amplitude afterwards. So the amplitude for us is 1. So that means my graph is going to have a max height that's 1 higher and 1 below the center line. So I mark those off here. This will be 3, this will be 1. So this will act as a max value. and this can act as a minimum value. All right, the next thing I look at is the period. So our period is 360. So 360 is actually halfway between 720. So that means I'm going to have a full cycle from 0 to 360, and then I'm going to have another one again at 720. Okay, so once I get the period drawn down here, so there's the first cycle, there's a second, I chop those up into 4 pieces. So I cut this in half at 180, and I cut this one in half at 540. Okay. So each cycle is split in half now. I chop it in half one more time. So 90 and 270. That one would be 450, and this one would be 630. Okay, the reason why I've done this is because I now know how to plot my points as I go through the graph. Okay, and I can draw a nice curve. The only thing is that I haven't done yet, and that'll be step 4. That's going to be the phase shift or the horizontal shift. So I like to draw that at the end. So, and let's say blue. In blue graph, I'm going to cover those 3 transformations, which would be like A, K, and C. And then in the last one, I'll use D, the phase shift. Okay. So this graph here will just be these 3. It's in the absence of the phase shift. So sine always starts at the middle, that middle line, and then works its way up. Okay, then back to the middle, back to the minimum, and then back to the center line. That's one full cycle. Okay, and then it's going to repeat again. So we actually have 2 full cycles in. I think we can do a better job at that. Let's try this here. You don't need to draw this curve here. If you just mark off the points, that might be good enough. Okay, so this isn't the full graph. This is everything without the phase shift. So the phase shift now, we'll do in a different color. Okay, the phase shift is right 45 degrees. Okay. So how much is 45 degrees on this graph? Well, this conveniently works out to 90 here. So 45 is half that. So I'm just going to mark off some ticks in between all those to show increments of 45 degrees. Okay, all those points move over to the right 45. So this point maps over to here at 45. And same with the next one. And they all just move over exactly 1 tick on the graph. Okay, I can draw this curve going nicely through like this. Okay, so this is going to be y equals, I just write out the final equation, sine x minus 45 plus 2. And that's the graph. So I always kind of follow this systematic approach when graphing. You could also do point mapping, where you take your main points for sine x and then put them through the point mapping formula. Okay, I don't really recommend doing it this way, but it works. So, but yeah, that's it for this example. I'll see you guys in the next video.